Hello, everyone, and welcome to this session on the edge for the digital economy. I'm really excited to be here. I want to thank the show and the conference for having and allowing myself and MEF to present here. I really believe that the digital economy is very massive, and MEF is playing a very pivotal role in this area. So let me just get into this. So a little bit about MEF, I'll start here and I'll get right into the presentation. MEF is a 20+ year forum that started with standardized carrier Ethernet and drove it to an $80 billion market and continues to grow massively. And with that, we have 200+ members, but 130+ service providers in our membership. And what we're working on in essence is this need for networks to transform themselves. Since most of our membership, our service providers, they're really on a network transformational journey. And MEF is the forum that's leading this network transformational journey, along with other SDOs. And together, we're all trying to make an impact to make sure networks are very software-oriented, virtualized, and automated. And with that, we get this full translation and conversion into this highly adaptive, highly secure network. So as I talked about, this digital economy is massive. It's a tidal wave of $6.8 trillion, according to some research, and continues to grow massively. And as I said, network transformation is a very critical role. Now, why is network transformation so important? Well, the use cases, they're not just IT moving the cloud. There are all kinds of new use cases emerging in digital transformation that has to do with edge compute and all kinds of applications like AR, VR, connected vehicles, IoT, and AI, ML with robots and manufacturing and warehousing. All of that are all new kind of digital workflows. And those kind of workflows, those digital transformation use cases really require an end-to-end frictionless experience from device to service. And that's kind of what we're trying to do at MEF is how do we enable that? How do we make a more modernized network that hasn't changed since the late 1990s with internet networking? And so we are now on this journey of completely transformation of networks as we know it. And it's started good, 5-8 years ago, but we are definitely well on that path. And what I'm going to cover is basically networks in network transformation have to be highly automated and interconnected, very high speed underlays that connect all the service providers together to give 100, 400 gigabits per second capacity in the fabric of the transports with all kinds of internet access. I'll go into that, and all kinds of access technologies, 5G, fixed wireless access loops, and so on. An application should just behave correctly from wherever the person, device, or user is, or application. They should just perform perfectly and flawlessly wherever the service might live. And finally, we see that cybersecurity should be built into this experience, that there's no idea that wherever the user, device, or application is, they are less secure or more secure. It should be work from anywhere, be anywhere, and be highly secure. And finally, with that, more and more, the clouds are just going to not just hybrid clouds now and multi-clouds, but distributed clouds. And that with that, edge plays a very important role. So edge with networks become very synonymous. And this is a very important aspect. So let's just start with what MEF has been doing from our roots, basically carrier Ethernet. We've interconnected the world over the last 20 years with the data plane of carrier Ethernet. We spent 20+ years of making an incredible specification of carrier Ethernet set of specifications that the industry has adopted worldwide. And today, everybody on the planet is interconnected in a very high-speed data plane of carrier Ethernet with IP on top of it. What we've now done at MEF is we've enabled this whole automation plane so that services can be turned up from anywhere in the ecosystem at cloud-like speeds. And this is very, very critical. And we've done this with a whole set of automation APIs called Sonata. I won't spend a lot of time in this, but the bottom line is it's a commercial side and an operational side of a set of APIs that from anywhere on the planet, any provider can ask any other provider to turn up services at cloud-like speeds. And with that, the whole idea of getting from an address, getting what's available to services, a price code, ordering it, and then all the operational aspects, including service OEM, performance management, fault management, service changes, and then finally all the billing and invoicing. So these are all the kind of use cases that has to happen in this ecosystem to make it frictionless between all the partners. The second thing MEF has really done and recognized is that with this high-speed underlays, there's overlays. And overlays become very, very critically important, as we know, because the world has moved to between overlays and underlays. And the technology behind that is Sd-Wan. And MEF has taken on being the standards organization for Sd-Wan. And I'm proud to announce that we're about to release our version 2 for Sd-Wan specification and all the certification that comes with that. So stay tuned. That should be announced this month or next month, and the work is being done. We're just waiting for final board approval. We've also undertaken a really critical aspect of Sd-Wan with this overlay called Universal Sd-Wan Edge. And what that means is we know more and more Sd-Wan's used in cloud-like offerings, whether it be SaaS clouds or IaaS kinds of clouds or PaaS clouds or anything. Everybody's looking to Sd-Wan as that overlay that delivers on that application performance guarantee. And we see that more and more, there are many, many Sd-Wan vendors out to the market, and more that there has to be interop. So our service specification defined the behavior for service, the subscriber buying that service. What this spec does is talks about how will Universal Sd-Wan Edge communicate with other vendors at a minimal interop level. So we cover interop at the data plane level, the management plane level, the control plane level, and the telemetry plane level. And this work is very important because we see more and more service providers going to put at their edges, thousands of edges, have to put an Sd-Wan edge, whether virtual or physical appliance there. And they don't want to rack and stack various vendor types to support that from different subscribers. They want to be able to interoperate with various vendor types of that subscriber's preferred choice. So this is a very important area because interop didn't get solved for Sd-Wan, and MEF for solving this. As you know, SASE's become a huge, huge hit, and that's because it allows the ability to work from anywhere and still be secure. And this is very important because work from anywhere is a very, very important theme, especially since COVID. So at MEF, we've also undertaken the task to define SASE. Now, while Gartner had originally put out SASE and the concepts, and it was brilliantly done and really widely accepted in the industry, what MEF has done now is defining, just like we did with Sd-Wan, we recognize as part of network transformation, cybersecurity is very critical. And this is our first foray into that, is delivering this SASE service, which delivers this idea of secure access service edge. So wherever the user is, device or application, they are secure through a cloud-like service that lives at any edge POP. So any edge POP or central location. And wherever the user or the flows of the application have to go, they have to go through the SASE cloud, get scrubbed. And so therefore latency becomes very important. And that SASE cloud is connected to all kinds of hyperscalers, including the internet, private clouds, public clouds, and so on. So this is a very important piece of work. Stay tuned. It's being baked right now, and sometime in 2022, I estimate in mid-22, we will have this as an official standard and certification. Also, as you know, more and more we're seeing a lot of cyber attacks, and we're seeing that the means to solve this is using credentials with authorization, so access control. So where can a device, user, application, who are they digitally, and what can they do, and in what context, sometimes time of day, location, so on. So we're working at a companion specification to SASE called Zero Trust. And this is the first industry standard again that we're defining in MEF on how Zero Trust will behave. Unlike other organizations that define kind of white papers, this is truly a standard to get everybody in line. And the outcome is a set, not only the language and the constructs and labels and all that everybody can use and point to, but also a set of attributes to become really the data model for APIs, as you can see in this diagram, between identity and access control systems are already in place today at the application level, and allowing that flow into the network layer level through ZTNA, so that there's only one area for doing policy and authorization or access control, whether it be user, application, device, and whether it's going to clouds or to data centers or to whatever. It should also define what access they're allowed in the network. So we see this is all coming together, and our zero trust work also defines and will define the API level of how the application world and that identity world will talk with the network world. So that's a big takeaway. So stay tuned. That one should come out also mid-22, along with the SASE work. Finally, we're seeing a lot about 5G and the role of 5G, and we see nothing more than slicing, network slicing being very important. And at MEF, we're also defining the service definition of how a subscriber buys slices and what that vocabulary, language, and so on is, but more importantly, what are the slice profiles? So while there have been organizations like GSMA and 3GPP to define slices on 5G, we're really defining what slices are from a subscriber buying that slice, and then having that slice go end to end, especially to edge compute points. And think about whether it be fixed wireless 5G or mobile 5G, one of these, even a fixed kind of access loop, they can have slices on them. And in MEF, we're defining now the 3 slice profiles called real-time slice, premium slice, and business slice. And they have a set of performance objectives, and they can be applied and bought from subscriber, and they can be applied across the whole wireless and wired infrastructure, wherever that, from source to destination, wherever that is. So most of you might say, well, isn't that an SD-WAN scenario? The answer is there are scenarios, for example, IoT connected vehicles, that they just want the slice. They're not going to implement an SD-WAN edge on their IoT device. They're just going to be 5G attached and tethered, and then they want a slice that they want to buy and get performance guarantees. And that slice could have some security postures on that in the future. So our MEF 84 and 126 is defining all that work and how that will apply into a 5G world and how slicing will apply end to end. And we have a lot of POCs in this area I'll cover in a second. We also are incubating edge compute. And people might say, well, why are you incubating edge compute? There's a lot of work already doing in edge compute. The answer is yes. There's a lot of today current offerings from edge compute, but that edge compute is really proprietary in nature. The subscriber buying the edge compute buys it from the hyperscalers, and they have their own definition. At MEF, what we want to do is, since most of our members service providers that are offering edge compute also, we want to have a standard language, vocabulary, definition around compute power, storage, network, so on, that basically the subscriber can buy, and more importantly, the ecosystem can buy and sell across. So if a customer wants to buy edge compute in one location of geography and wants another edge compute on the other side of the globe, we know no service provider solves all of that. So the ecosystem can negotiate through our automation APIs, find the best edge compute to meet that subscriber's need, and offer that as a retail offering. So stay tuned, more happening here. This is just incubating, but we see edge compute, as you know, very, very strategically important to network transformation. So one of the key areas that now we are embarking on is taking all our assets in that inter-provider automation and moving them and focusing towards the enterprise. We see a lot of use cases and need where this automation, where any of these applications, users, IT, OT, operational technology, developers, and so on, they want to be able to buy services at cloud-like speeds, and they want to buy through APIs. And so at MEF, we're taking all our assets that we did between the inter-provider, that's commercial APIs and these operational APIs I talked about, and then focusing to the enterprise. And we see a lot of multinational enterprises and all kinds of connected IoT kind of applications that wants to be able to use these APIs to buy services from a service provider, things like security, cybersecurity services, managed security, managed connectivity services, slicing services, all these kind of network services that these applications need, and they want to buy that from the edge and using a set of automated APIs. So stay tuned, MEF will be launching and repackaging all our Sonata APIs facing the enterprise called Cantata and Allegro. So as you know, next generation edge scenarios are massive. There are many, 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 many scenarios. What I'm going to cover is just 2 examples that we've shown in our POCs of how edge and how applications working with the edge are making a difference. And these are real scenarios, real POCs, proof of concepts working, being demonstrated. The first one I like to talk to is with a set of our members, Spectrum driving this with Juniper and Equinix. And the real power of this is that at a live stadium, users can view in real time on their smartphones different viewpoints of what's going on in the game. Now, not only is that happening with the users at the game and getting different viewpoints from different cameras, but that's also streamed down into hotels nearby or other areas. And those hotel guests, for example, this Waypoint Resort A on the very top right, gets to see those different viewpoints also from the game. And that's all being driven by slicing. And this becomes very important, this slicing happens. Now, in areas of where they don't have slicing, and Waypoint Resort B doesn't have slicing go through it, the slicing is then converted to SD-WAN, and SD-WAN is used to deliver those performance objectives to make sure that in real time, both hotels can see the different viewpoints of how the game is being played out. So this is very powerful, that not only it's an on-demand and can change the viewpoint at the stadium, but it can be done anywhere really across the planet in some timely manner. So really the point of this is to show this as an example, and we've done this in MEF-POC, and I really would love if you could go visit mef.net and see some of these POCs. We have some exciting proof of concepts, and this is one example. Now, another really amazing example that's showing the idea of how edge and applications work together is this idea of application optimized SD-WAN. It's a MEF-POC driven mainly by Cisco. And what it shows is the idea that a DevOps programs into their Kubernetes cluster and their application, their microservices, whether it's a voice, video, or data stream. In this example, it's a voice. The API talks to an SD-WAN controller and says, hey, this flows are going to be voice oriented and treat them the right performance objectives. And the SD-WAN controller just translate that when the flows start up to then apply the right performance objectives. Now I'm kind of simplifying it. There's a little more to all of that in pre-setting this up. But once it's pre-set up, it actually flows just like that. So think about, we truly have applications being programmed by developers to how they want the performance of the application behave and how the network should treat that application. And the network just does that with no pre-provisioning from anybody. And as flows start up of voice, video, and data, the right application performance as programmed in the SD-WAN environments and delivering that performance guarantees. So really, really powerful ideas. And this is on also our MEF.net site, and you can see that POC. So with that, I'm coming to the end of the presentation. I love you to get more involved in MEF. At MEF, we're really being very impactful around network transformation. And it's really important that if you come be part of this journey, you become not only a thought leader and help to influence and help to move where network transformation is going, but also be part of a community to grow together and to advance all of this work. We have delivered tremendous certification in all kinds of areas in this network transformational work, including Carrier Ethernet, SD-WAN, and we'll now have new certification in SASE and Zero Trust. And we have tremendous implementation of our APIs that we announced in the inter-provider side, and soon to be we'll announce these APIs facing the enterprise. So with that, I want to thank you for your time, and I hope you do join and visit MEF, MEF.net. And thank you so much to the show organizers. Layer 1, 2, 3, we're really looking forward to being in person one more time. And hopefully that'll be very soon. Take care.